All right, one of my favorite units in AP Environmental Science, Earth systems. So the question is, are hybrid electric vehicles as environmentally friendly as we think? See, many people in environmental science community believe that hybrid electric vehicles, or what we call HEV, and the all-electric vehicles are some of the most exciting innovations of our last decade. Cars that run on electricity or in a in a combination of electricity and gasoline are much more efficient in their use of fuel and similarly sized by their internal combustion components, which are also really small. So some of these cars use no gasoline at all, while others are able to run on as much as 1 gallon or go twice the distance as any other car on the same amount of gas. So, although HEV and all these all electric vehicles reduce our consumption of liquid fossil fuels, they do come with an environmental trade off. And the construction of these vehicles use these really scarce metals like neodymium, lithium, and all these like lanthanums on the bottom rows of the periodic table that if you remember, like neodymium is needed to form the magnets that are inside of the electrical motors, and lithiums and these lanthanums are used to compact these high performance batteries inside of the vehicles. So at present time, it appears that there seems to be enough of these precious metals available in the world to meet the demand that Toyota has put out there, which is about 3 million of these Prius vehicles. And Toyota obtains its precious metals from China. And there's also enough supply, at other parts of the world, like geologically speaking. There's some in California, Australia, Bolivia, Canada, and elsewhere. But most of these deposits have not, been mined yet. So until this happens and we start mining these areas, some scientists believe that the production of these vehicles and these all-electric vehicles will eventually be limited by the availability of these precious metals. So it's not only these lanthanum deposits, but if you look top hand, left hand side here, this is, oh goodness, sorry there. This is neodymium, and then over here we have lithium carbonate, and so what you're seeing here are the mines. So not only are these metals there's scarcity, but also the metals needed to make these vehicles, these all-electric vehicles, we have to consider how these are acquired. So whether mining occurs or not, there's a lot of environmental consequences of pulling these materials out of the ground. So material extraction leaves like this landscape just very fragmented by holes and road construction and loose debris and all of this stuff that comes along with this mining site. It basically alters the natural habitat. So then erosion occurs, and then that leads to water contamination, and all of this is a result of mining. So a typical Toyota Prius uses approximately 1 kilogram, that's 2.2 pounds for us Americans, of neodymium, and about 10 kilograms, which is 22 pounds, of lanthanum. So mining these elements involves pumping acids into deep holes that dissolve the surrounding rock, and then they remove all of this acid, and it comes up in this like mineral nasty slurry. And lithium is extracted from certain particular rocks, and it exists in the ground as lithium carbonate, and it's extracted from these brine pools where the mineral springs are adjacent to these salt flats underneath the ground. So both these extraction procedures and the type of surface mining that's involved in finding these metals can have like severe environmental impacts. I mean, first of all, the holes, they're open pits. And so just that ground disturbance created by mining these minerals and metals provide an opportunity for air and water to react with other minerals like rock and sulfur from the acids and all of this like nasty slurry that, that doesn't exist when the minerals are in the dirt and deep underground. All right, so as the acid mine is drained, it basically flows all over land, which ends up underground, eventually percolates underground, into our aquifer system and rivers and streams, and it dissolves other metals that are actually in the ground too, and other elements. And as a result, the water near the surface, where the mining operation is going on, is extremely acidic. And sometimes it even has a pH of like 2.5, and it can be even lower. And so it may contain these harmful levels of dissolved metals and minerals. Just one problem after another. And so this current HEV technology does not represent a step forward, in research or in reduction of the use of fossil fuels. However, to make good decisions about, resources, we must first understand the costs and the benefits of mining.